All right. Hello, everyone. I'm back after a week break. Uh, had to deal with some personal issues, but all that is behind us now. I missed you guys so much that I decided to stream today on Saturday and just try and get back into the swing of things. So, with that being said, I'm Cowboy. Welcome to today's stream. We'll be doing some coding challenges to kick off, followed by working on some more TryHackMe CTFs. Hopefully we can get back to the one we were working on and try and finish that up. If not, I did find some other ones that might be interesting for us to try and work through. So, without further ado, let's get some nice lo-fi going and go ahead and pull up our challenge for the day. So I wanted to go back to this Codility. We left off with stacks and queues. We got most of them done, but let's go ahead and skip to the leader, Dominator. I love just jumping into these. It's been a while, so gonna have to stretch my brain out a little. It's all right. I'm fully caffeinated and ready to rock and roll today. Famous last words, I know. Hope everyone's having a good weekend. It's a little... Oh, wow. It's been that long that it has to give me the tutorial again. Wait. Let's go back to our old pal Python. All right. So, you can write standard out for debugging purposes. This is a debug message. An array A consisting of n integers is given. The dominator of an array A is the value that occurs in more than half of the elements of A. For example, consider an array such that 0 is 3, 4, 3, 2, 3, 1, 3, and 3. So the dominator of A is 3. Because it occurs in 5 out of 8 elements of A, namely in those with the indices 0, 2, 4, and 6, and 7. And 5 is more than half of 8. Write a function that, given an array A consisting of n integers, returns the index of the element of array A in which the dominator of A occurs. Oh, come on, not this index. Okay. The function should return -1 if array A does not have a dominator. For example, given A is 3, 4, 3, 2, 3, -1, 3, and 3, function may return 0, 2, 4, 6, and 7, or 7, as explained above. Oh, or 7, so it's one of them. An efficient algorithm for the following assumptions. Here we go. This is always the kicker. N is an integer within the range 0 to 100,000. Each element of array A is an integer within the range negative big number to positive big number. I wonder why it's specifically this number. That must be like maybe a buffer or something. The limit to how big an array can be or something like that. I don't know. Alright. So let's start with our notes. We know that we just need to return one index location of the dominator. I guess I'm gonna write that. Yes, no dominator. They couldn't have picked a different word. This is so weird. Get your head out of the gun. If no dominator, return -1. Alright. Seems straight enough. So I'm thinking to start off with, if we make a dictionary or set and just count how many times that pops up, we organize the set, and then we should be able to just figure out which one has the most elements. And if all the elements are the same, then return -1. But that doesn't sound efficient. I wonder if we could do something along the lines of... This might sound a little weird, but if we order the array, count how many of that number store one index of it, iterate tree, because we don't care how many numbers there are. We just want to find which one occurs the most. So if we store one of the index and its count, move to the next one. Is it bigger? Yes. Update. No. Move on. Does that make sense? I think that makes sense. Whether it's efficient or not, I don't know. That's a tough call. Tough call, coach. I say, let's go ahead and we'll test it out. What do we got to lose? So that one should, so the first one should return 3. The second test should return -1. One is like, just generate a bunch of random numbers to test, but that'll be fine for now. Okay, so we can order our array A. Wait, doesn't the absolute, isn't that the built-in function? Return the absolute value of the argument. Because when there was a way to the absolute value, that's probably just counting. Because I don't think we need to know the size of the, we don't care how big the array is. It doesn't have to be, you know, well, what was their example? Like 5 out of 8? Yeah, it occurs 5 out of 8 times. But if we see a number pop up 5 times compared to the other ones. All right. Oh, and since it can be negative, we have to be careful of that as well. So, or x in range of the length of A plus 1 we'll just have temp equals our number. Let's see. Oh, I know. What if we do index on the first element? Maybe. If x equals temp, and then we can say count plus equals 1. Yeah. Hmm. Index. All right, cool. Let's just start our index at 0. And then each time we loop, we'll just increase our index. And then else we need to do... I was going to say, like, if it doesn't equal, that means that we've hit a new number. And we need to switch to the new number and start counting that. But this would also include, like, let's just start making comments, because we know we're on the right path. But we need to do move to new number, compare current count to biggest, and then either we update index or move on. Right? I think that's right. Why are we getting an error here? Oh. Wow, it's been that long that I forgot double equals. Yeesh. Hey, you man. Expected an indenting block. Oh. There's some bar pass. What else? All right. Yeah, that's fine. Well, what was that Python, like, count elements thing? The built-in Python counter. I don't know what that is. That's scary. That Chrome's just like, let me show you your history. Okay. Oh, no AI. We're not looking at that. Don't worry. We didn't look. Counter class is a special type object data set provided with the collections module in Python 3. Collections module provides the user with specialized container data types, thus providing an alternative to Python's general purpose built-in like dictionary, lists, and tuples. All right. Creating a counter class using a list as an interval container. This might just work right off the bat, right? I think it will be able to just give us the answer. Oh, but we gotta know the index. So it helps us solve one, but not another. and we don't know if it's going to be efficient or not. I mean, I say we just go for it. We'll just start playing around with it. It's got to be useful somehow. So then, let's just see if we can keep doing it this way. So, for example, let's just say that we have an array 1, 1, 2, 3, 3, 3, 4. All right. So the answer should give us the index of one of these numbers. And I realized what I just did. In order to have this work, we need to have the original order of the array. Shoot. Can we be cheapy? Maybe. That'd be great. And then we can just do like find big number. I'm pretty sure the contains function will give us the index. Python contain find in array. Loops for deeps. Yes. Index equals array.index. So we can just use this index method. If we can use counter and then just index on whatever that is and return it. Counter. All right. Counter. I barely know her. It's been a while. Let's see. So if we counter A, which is our iterable, what built-in? There's just most common. And then if we do let's just call it common equals counter, most common. And if we import array, or can we just do idx equals a dot index common. per ID X. All right, class, what's wrong with this solution already? The problem is, what if the most common isn't the most common? It just happens to be the first one that's the most common, and they're all the same amount of occurring. Let's just cut out that code and let's see what happens when we run this. It breaks. Did we get any of them right? So a.index, what are we returning? Because it looks like we're returning an array of key value. So this occurs once, this occurs once, this occurs once, this occurs 5 times. So maybe if we do that. Closer. We gotta get this first element here. So common puts it at the beginning. And then if common indexed on 0 equals common index on 1. So checking these two values out, we'll have our last ones. N is an integer within the range of 0 to 100,000. But what I'm trying to say here is if the occurrence happens twice, those two elements, the values should be the same. And then it's just figuring out where is that indexed. Does this make more sense or less sense than what we were doing? Okay. It's fine. Most common, again, second common. We can do whatever we want. It's our code. We're also going to need to check if the length of A is something. The length of A equals 0. How long? So N is an integer within the range of 0 to 100,000. Yeah, so if it's 0 or if length of A equals basically we have to say like if it equals 1, 0, 1, or 2, then just return -1. Hmm. I think we need the if. So that should start to set us up pretty nicely. Although we did just lose what we were working on before, but that's fine. Still have to worry about the index, but we'll worry about that later. We can do if most common indexed on the first one is greater than or equal to second common indexed on the amount of times turn, and then this is where it gets tricky because we have to return the index of it. Which I guess is where we can do a dot indexed on most common. Oh, and that would be on the initial value. Else, we have to oh, you know what? I think it would be an else if. Because if it is equal yeah, I understand. That's what I want you to do. Oh, indexing on that. Okay, good. Turn -1. Okay. Close. I don't know how we got 0 here. We did get the first test right. Okay, yeah, it doesn't return the index. I think we're good to go. Let's hope this works, because we want to do some CTF challenges today, all right? Let's go ahead and submit our task. Cross our fingers. If I had fingers. Okay. Not bad. 58. 58 isn't bad. Oh, but we, all right, correctness 37. But we did perform at 100%. So I don't know what we got wrong. All different and all the same elements. What? What does that even mean? List indexed out of range. Line 20. Okay, wrong answer. Got 10, but the element is not a dominator. Value 2 has only 10 occurrences. Small half positions. Got 10, but the element is not a denominator. Value 2 has only 10 occurrences. Oh, so it is checking the size thing. Dang it. Extreme, empty, and single item. Got -1, but dominator exists. For example, 1 position 0. Alright. But we were able to do the giant ones. Okay, sure. So we just messed up on the edge cases. Got 1, but element is not a denominator. Value 1 only has 2 occurrences. No, wait. It does show us. Yeah, why didn't it show? Extreme half. Alright, I think we can try that again. Let's go ahead and give that a shot. Leader. We'll give ourselves another 20 minutes on this. So I think if the length is 1, then we need to return the first element. So we have our else if. Index on 0. That should be good for that. And then if our most common is that and most common index on 1 is greater than the length of A divided by 2. That makes sense to me. Just want to make sure that that's properly nested. There we go. So if our most common node is bigger than the second most common, and the most common is greater than the length of A divided by 2 floored, so we round down, which means else we would also have to. Isn't it just else return -1? Because if this isn't greater than that, yeah, I think we're good. I think we can just say else return 1. Sadly, I will have those tests. So let's go ahead and just submit again. We do it live, baby. We do it live. Ha. Ah, there we go. All right, I'll take an 83. We just forgot some of the edge cases. I don't know why we keep running into this error, though. Mine 22. Small non-dominator. All different and all the same elements. What? The extreme, empty, and single item. But it worked for everything else. I think we call this a win. I think that's good for now. So we went from like 50 to 83. I forget what the correctness was, but yeah, that's a win. All right, now we can switch over to our capture the flag. And I don't know if you guys want me to do a new one or if we should just try and pick up where we left off from the old one. I'm good with either. So I did find this one CTF called Lo-Fi, which just hear some lo-fi beats, relax, and do a CTF. I think we just try that one. We'll go for it. We'll go ahead and join that room and we can get it booted. And I'll start up the Cali box for us. And I'll also make sure you guys can see the screen. But basically, this CTF is going to be access this challenge by deploying both the vulnerable machine, pressing the start button, and then, navigate the following URL using the attack box and find the flag in the root of the file system. So we just have to work our way to root. We can check out similar content on TryHackMe. That's fine. Note, the web page does load some elements from external sources. However, they do not interfere with the completion of the root. So we just gotta climb the file system until we get to the root. I'll switch over to this. Make sure we can share our root. And then gonna go over and start our Cali box. I think we'll start a new window too, so we can just jump right into this and still hold progress from the last CTF we were working on. And I love just having the ability to have multiple workstation. I will start up here. Let me go ahead and switch you guys over to our Cali box. All right. Boom. So the flag is in the root folder. We just have to make sure we connect to our sudo open VPN. Nice. minimize that so we don't accidentally lose our access. Go ahead and pull up a new Firefox 10.10.10. But 10. All right, our VPN's working. The box we are attacking is located at 10.10.175.195. So let's go ahead and go our documents, projects, CTF. Really wanted all this in a different directory. I know I'm such a scrub using a GUI. Sue me. I think this was called Rollnet. Was our last one. Just throw everything in there. Then we can have a new folder called Lo-Fi. Luffy. Open up our note-taking app. All right, this will just minimize for now. Let me know if you guys need me to zoom in or not, but it's just going to be notes. Let's see here. I can like. Yeah. So let's go to an IP address and see what we can find. Hold on a bit. So it connects to YouTube. We have relax, sleep, chill, coffee. Oh no, it's broken. Oh, a couple of these are broken. But I noticed that our URL has a question mark page equals game.php. Click here to go home. It's always good to inspect. And in fact, let's just look at the page source. Style sheet, navigation. Category widgets. Those are all the different pages. Container footer. That goes jumping out. We might be able to do a XSC. To make our way through here. Good. Let's see what the hello search does. Anything? Whoa, 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 that's so much. That's so much. Let's start over. Hello. Okay. So search equals hello. We get a post. Like a bit. Oh, Jason. Response is just the page. Like an event. Optional. Embed. And decode. Oh. Where's that? From YouTube. Yeah. YouTube.com.YouTube. YD, posting. We don't really care for any of these other domains. We want to focus on the box we're trying to get into. All right. Nothing super useful. Let's go ahead and nmap all the ports on this 10.175 and 195. Oh, shoot. That's not all the ports. That's just for the Redis from our previous. History, rep, and map. That's what I was for. So, nmap, all the ports. Sure, we'll do all this. We'll make our nmap file. 175.195. Should be good. So while we have that running, we can open up a new tab. Were we able to find out what this is running? I think I did see that it's running on some Ubuntu box. Back to this page source, document type. Footer. Java injection browser. I think that's what it's called. It's probably not called that, but web app alert inject. I knew it was Java. Client side injection. Actually, I didn't see any like JS files. This is PHP. Character set, UTF-8, viewport. Sure. Style sheet. Oh, there's our integrity. We saw that last time while we were Larry. Action method get. Or if I just do like Let's see. Password. Let's see if that works. No, nothing. We're looking for something that can give us feedback. Those are opened in. We weren't recording. Yeah, we did again. Can't find its favicon. The response was just another. I mean, we could just keep adding some more dot dot dot. So far up you can go. And now, the hints from the room are LFI, path traversal, and file inclusion. So that's why I tried this dot dot dot, hoping that that would get us something. We might have to encode it better, perhaps. So let's pull up Cyber Chef. We can make a URL encode. We'll say Etsy password. Like that. You know, if we go back, can we just paste that in here? Oh. All cookies, the headers, we gotta okay. See how our nmap's doing, still going. Really. File inclusion and LFI path traversal. Path traversal, local file inclusion, path traversal. That should be somewhat what we're doing. In PHP, a vulnerable script for including different web pages could look like this. Simple payload. Oh, did we see that at the bottom here? I think that might be it. You might be able to leverage that page. There we go. We got it, baby. I knew we were onto something. All right. So now we have all these users. I think, technically, can we just... Let's see if we have access. It's probably called flag.txt. All right, flag does not exist. What does exist? It's not gonna give us... That's our traversal. Oh, yeah, we should probably grab this for our notes in case we need it. Oh, long notes. Bash. You know what? It doesn't matter. We have it saved somewhere. There is a nobody, bug reporting system, admin, gnats. Let's start at the top. Games, man, spool, backups. So I wonder if we can... So we did the file path traversal. What was that? Technically file inclusion, local file inclusion. File directory. Thanks for the spam. Appreciate it. Probably should have just went to the OWASP page. Is there anything else in here that might be useful to us? There's this /I that seems interesting. Stray I tag. What is the I tag for HTML? Defines a part of a text in an alternate voice or mood. Content inside. What does that mean? Default values, font style, I Footer container. Those are, and that still going. All right. Yeah, it's probably going to be a while. As you can see, the file name is taken from the HTTP header request. The attacker abuses this script by manipulating the GET request. The attacker first uses a poem file upload functionality to upload the following poem. The attacker submits a request to include the poem. Is to be able to include modules dynamically. The following code snippet from the index dot. All right. It's taken directly from the get HTTP. Therefore, you can include welcome.php as follows. The attacker first uses the poem to upload the functionality. Upload poem 42.txt, which contains the PHP code source, the pentest monkey reverse shell. Then the attacker manipulates the get request to include the poem instead of the module. As a result, the application runs the reverse shell, granting the attacker access. All right. I don't know what pentest monkey is, but it might be something worth checking out. I think if we can get this to actually execute some code, like maybe sorry, whoing line doesn't exist. So it is local file inclusion. Can do file remote execution. See what examples we can find. Right, yes, we know we saw the Etsy file. Directory traversal, we did that. There we go. Remote code execution. Combined with file upload vulnerability, we don't have that though. Compound matters. And then, yeah, they just do that. As you can see, contact PHP. Files that are printing to a page. Right. Okay, yeah, that's exactly what we did. Path truncated. I think what we want to do is stop the search and do some other injection. Because here's our request, our response. Is it just going to be the whole page? I want to see the wall. So, can we do something like then sh who am I? And if we just convert that into URL, maybe? Let's see if we can get some code execution. Oops. A little too far there. All right. PHP reverse shell. This tool is for illegal purposes only, free software. This script will make an outbound TCP connection to a hard-coded IP import. Recipient will be given a shell running as a current user. Use of string select. Or wait, oh, how can we skip that space right there? Let's remove our page equals. Let's see if we can copy this raw into our page equals. No, it's still. Why is it not encoding? Okay. So we do have access to that, which means we might be able to get remote code execution if we set up a proper reverse. Yeah, see, it's missing this %20. I'm able to just do that now. Okay. We're able to see it. We're able to. Are we able to run it though? Well, let's look closer at this PHP reverse shell. This might be useful to this. Immunize ourselves if possible. Spawn a shell process. That does nothing if doing themselves. Let's see if we can just search simple PHP reverse shell. A tiny PHP. If you want to connect to your computer with internet or VPN, and that grab publicly, we start our MCAT PHP script. I use the physical IP address, then the 8080. The MCAT now says connected, but the problem is when the commands of the web server where it hosts the URL. ngrok makes localhost port public. Okay, we can ignore that, I think. Let's see if we can just run. Well, it's still our own VPN. Nmap still running. We'll open up our notes. Paste in our possible injection. This is what I was looking for, the exec. Maybe. So didn't do that. It did something weird. Sorry, does not exist. And do I need to close the PHP? Oh, I wonder if one of these has something else we can use in one of the other pages. Although we're probably going to get closer with one of these. Okay, it's just question mark and oh, you know what? I bet you it's running this command. It's just not showing us the output. Or the output, it's going to standard output or whatever it's running. So we have this set up on our notes properly. We can say connect to ourselves, and then we can say whatever our port we want to use. So we'll do 10.6.41.79. And let's, sure, 1, 2, 3, 4 sounds fine. All right, and then we have our question mark end. That should be our PHP. And we say end cap, listen on 1, 2, 3, 4. We can grab our payload, hopefully. Let's see if we got anything back. Nothing. Oh, it does not exist. I don't know if we need to encode this. I think we're getting a little bit into the weeds here. Let's try PHP, this directory. Well, all right. Okay. In this example, a script uses the exec function to execute a ping command. Step into the code injection. And they just threw that in there too. Right? That's what it looks like, at least. Let's go ahead and pull that up on the notes. Do we even need the PHP part? Yeah, I think we need the PHP part. Our nmat finish. Let's go ahead and take a look at that as well. Okay. It is Ubuntu, like we did notice. Port 80 is open. Port 22 is open. So it has SSH available. Are we able to see the SSH file? That wouldn't make sense, right? Who are we probably running as? System, sync, games. Well, maybe we can just grab the root. And open SSH 8.2.1. Go ahead and copy that and bring that over to our exploit DB. And let's see if we can search for something that might help us here with that version of OpenSSH. No results found. Maybe if we search 8.2. Still nothing. We're able to read files. What else can we do with that? Is it literally just like copy and paste this entire thing into change this and change this? Usage. We can go here and see what it says. Modify the source. Get ready to catch the NLP on port. All right. Upload and run. Whatever vulnerability you've discovered to the website, upload to php.php. One script simply by browsing to newly uploaded file. We don't have an upload function. We have traversal. File inclusion. PHP execution. No, 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 no. We don't want the manual. Okay. You should try the exec and see if we're able to even get anything. Sorry, exec doesn't work. We wrap it in PHP, maybe? Sorry does not exist. Hmm. What else can we try? Boot. I think that txt. Giant txt does not exist. Is it local? No. Let's see. We'll just slowly work our way up a directory, maybe? Hmm. I mean, I want to gain access to this, but it may be hidden somewhere else. Find the file system to find the flag. Oh, I didn't realize it actually worked. It's only 3 directories up. All right, let's try it, I guess. Hopefully that's the right flag. And we did it. Wow. I don't know why that took us so long. I think that's what just ends up happening is after a while, if you're too focused on something, you are digging too deep, and that's not going to help anyone. All right. I think we might have to call it there. Let me check. Hmm. We might be able to do one more, or we can just call it a day here. Yeah, I think we're gonna have to call it here. This was great coming back. This was pretty fun uh CTF, pretty easy reflecting back. We just tried to go really deep based off of what we learned. Hopefully we learn for our next CTF that we do. Always try the basics first. Don't try and overthink it. There's always a clear path. And if you find one exploit, that doesn't mean you need to go hard on that exploit. So thanks everyone for tuning in. Make sure you like, comment, subscribe, follow me on Twitch, Twitter, YouTube, X, all the good stuff. And hopefully, if I don't see you guys tomorrow, I'll see you on Monday. We'll be probably picking up right where we left off on that other CTF. I really want to get back to that. But thanks for stopping by. Thanks for watching, and I'll see you next time. All right. See ya.